Bueno, hola a todos.
Hola a
Mayra,
todos.
Gio, bueno
Hola.
tenerte por acá, Mayra, nos hacías falta.
Mayra, estás
Sí,
de vuelta
volví.
por fin. Por fin.
Volví. Varias personas me preguntaban que qué había pasado, pero yo no necesitaba un poquitico de break. Pero no, ya volví.
Genial que estés aquí y pues
Qué
hoy
chévere.
es un gran día, ¿no?
Total, hoy es un súper gran día para la
Bien.
comunidad.
Hola, ya se están conectando por aquí. Está Elvis Romero, está Andrés. Porfa que nos confirmen si nos ven y nos escuchan bien. Esperemos unos segunditos que se vaya conectando más gente. Hola Jorge, Yerlis,
Viejo José,
Hugo, Don José que no falta.
Sí,
Todo
nuestro
bien, todo bien.
top fans.
Top fans de Angular Bogotá. Leonardo, bueno, empezó a llegar un montón de gente. Lo de siempre, porfa, pónganos desde dónde nos están viendo el día de hoy. Hasta me asustaron con el saludo, dice Andrés. No, nada de susto. Hola, saludos. Listo, Ricardo. Bueno, yo creo que nos escuchan y nos ven bien. Sí,
Ricardo,
yo creo
genial,
que
desde
sí.
Honduras.
Súper, mira.
Qué
Está
bueno tenerlos
Yerlis
a todos
desde
por acá.
Envigado, Bogotá, Perú, Venezuela. Una persona más de Bogotá, genial. Bueno, chicos, yo creo que estamos listos para el gran evento del día de hoy.
Tenemos un gran invitado,
Hoy,
muy querido por la comunidad, uno de los desarrollos, yo creo, más insignias de nuestra comunidad, ¿no?
sí, así es. Creo que es un gran referente para todos los que estamos metidos en Angular ya hace algún tiempo. Admiración por el trabajo que hace con comunidades, con todo lo que hace para el soporte a todas las comunidades. Y hoy pues es un día muy especial porque no sé si es la primera vez que dará una charla para una comunidad de Latinoamérica. Creo que sí. Así que es genial. Mayra, que ha tenido la posibilidad de compartir un poco más con él, creo que nos puede contar un poquito más del invitadazo que tenemos hoy.
Bueno, creo que es la segunda charla. Hace un tiempo
¿Sí?
vi que dio la charla para Puerto Rico, si no me equivoco, Costa Rica, uno de los
Ve.
dos, no estoy segura. Pero sí, la verdad, como que es bastante importante para nosotros y con comunidad que él esté aquí, o sea, que realmente participe en la comunidad, porque primero la agenda pues súper full, para los que no lo conocen, él trabaja puntualmente en Google. Entonces, imagínense la agenda normalmente que tiene. Además, pues su trabajo o uno de sus roles principales es conectar con las comunidades. Entonces, todos sabemos que esto es como súper demandante, no solo conectar con comunidades de Estados Unidos, sino de Latinoamérica, de Europa, etcétera. Entonces, una de las cosas que promueve principalmente es la participación tanto de él como del Angular Team en general en conferencias, en meetups, etcétera. Entonces, nada, es súper chévere que esté aquí, que nos pueda apoyar, es como un gran logro de la comunidad. Y nada, es una persona súper muy dada, obviamente para este rol pues tiene que tener mucha comunicación y tacto con las personas, o sea, es una persona que habla muy tranquilamente con cualquiera. Obviamente en mi nivel de inglés pues no hemos hablado tanto, es como que hola, muy poquito, pero sí, es súper chévere.
Genial. Bueno, Nico, ¿de quién estamos hablando? ¿Ah?
Entonces, démosle la bienvenida, vamos a cambiar a inglés
Oh
para
my gosh.
Switch
introducir
to English.
to Stephen.
Woo!
Hello, thank you very
Hola,
much for being
Hello,
here.
Stefan.
hola a todos.
Hola, Stephen.
How's it going?
So, Steve, good. We're excited. We're a little
Everything good.
nervous to have you
Yeah,
here.
yeah.
Don't be nervous. We're all global citizens. We're all here together.
Yes, obviously.
Thank you
Stephen,
very
welcome
much.
to Angular Bogotá.
Yeah, I wish I could be there in person. We've talked a bunch about me coming down, and like we were making plans for NG Columbia for the last like 7 years, and then the new event came up. And so there's just so much exciting stuff going on across Latin America, and I wish we could be traveling right now.
Yeah.
Great.
Soon we will be traveling again and hope to have you here in presence.
That would be awesome.
Yeah, don't remember that because I am so sad with the Google I/O. I was expecting be there this year.
Yeah, it's the world is a different place than we thought it was 6 months ago or 7 months ago. So we're all trying to adapt. I know our whole team is like trying to figure out, okay, we had some of it all figured out because Angular is a global community. We have contributors all over the world, so we had a bunch of it figured out, but we were still very used to meeting in person and like walking over to someone's desk. And so now it's like, okay, this is actually a great equalizer because now like we have to treat everyone equally, and like it's much easier to bring in people from all over the world, but it brings its own challenges. So for example, I'm on a team with a bunch of people, and one of the people is on, they live in Australia, and the other person lives in Switzerland. And those two people can never be in the same meeting.
Yes, I think with all this thing about coronavirus, we start like doing this online meeting. So we are so excited because in the past we just created or organized just face-to-face events, and right now we are online community and online community. So yes, I think that brings a few good things like this.
Yeah,
I'm
great
excited.
opportunities. We are all learning from this, and yeah,
Yes.
we need to get the best of it. And look, Stephen Fluin is in Angular Bogota. Really
Yeah.
cool.
Yes.
Oh my God.
Okay, so we have a little announcement to do because of Stephen is here. We have 50% off of the tickets for NGConf. It's gonna be the online conference this year. So use the code Stephen in Angular Bogota, and you will get 50% off on the tickets. This is gonna be the conference this year. We making a lot of effort to do it a great online experience. So hope to have you all here. Okay, so Stephen, the Angular Bogota community is yours. The stage is yours.
Awesome.
Welcome.
And thank you. All right, so I will dive into my presentation here. So today we're talking about Angular performance best practices, because there's a lot of developers out there that are trying to figure out, okay, how do I build faster applications, better user experiences? And so I wanted to break down some of the most important tips and the things that the Angular team is thinking about that tries to really help our developers. So as I mentioned, my name is Stephen Fluin. I'm on the Angular team at Google. And really my job is awesome. I used to get to travel the world, but now I get to be virtually around the world. And really my mission has two parts. First is to help people like you be successful, really trying to give you best practices, build tools that solve your problems, and really make your lives easier. And the second part is really understanding what it's like to be a developer out in the world, whether you're a brand new developer just starting out in your career, or whether you're a senior developer, you've been doing it for a million years and you want to just know kind of the latest tips and tricks, and you have different experiences and different wisdom. We want to reflect all those needs onto the team so that we're making the best product that we can and evolving things as we go. So Angular is always trying to get better, and so we're always trying to innovate and come up with the kind of best ideas to support everyone. And the only way we're able to do that is by listening and being part of communities like this. So thank you again for putting on this event. I think it's really important when we talk about performance to start off talking a little bit about some of the things that the Angular team values. And so when we talk about our values, we generally talk about three things, which is apps that users love to use. And we chose this one intentionally as coming first, because at the end of the day, every engineer out there, every piece of software that we build is ultimately trying to benefit some human out there. And oftentimes in software, we get pulled away and we get abstracted away from understanding and seeing and connecting with those humans. And so we always want to try and remember that human that we're trying to serve, because when it comes to making applications better, if you're not making the lives of your customers better and the lives of your users better, you might be doing the wrong thing in the medium term. But at the same time, while we want to deliver great user experiences, we also think that the only way to do that successfully is to improve the apps that developers can build, make it so that developers love building these applications. Someone said this to me in a very interesting way, which was that we want to make application development easier, or you can think of it as costing less, so that applications that never would have gotten made get made, because every application is out there as a business decision, right? Like, is the value we get out of this app worth the cost? And if we can lower the cost, we can actually make better applications, and we can make things exist that never would have existed anyway. So really focusing on the developer there. And last is a community where everyone feels welcome. Angular is only successful because we have a huge community of people out there that are passionate about Angular and sharing their passion with others. So going to events, giving talks, writing blog posts, filing issues, building libraries, evangelizing best practices of their team. There's so many different things out there that people are doing. And that is, again, why we're successful, right? We're successful because this community has so much momentum. It's because it's a lot of people coming together to collaborate and work together and make each other better. So a huge thank you for being a part of that. So we're going to go through this in a few different parts. And so we're first going to talk a little bit about some of the tactical things that you should be doing to try and figure out the best performance best practices. Then we'll talk a little bit about how architecture should be influenced. Then we'll talk a little bit about how JavaScript should be served in general, because this is something that we often forget. And then we'll just end up a little bit talking about the future and kind of where we can go from here. So to dive in, there is this idea that performance matters. And if you're attending a talk called Angular Performance Best Practices, you probably already believe this, but sometimes you need a little extra help to justify this and explain it to people in your ecosystem, to your boss, to your colleagues. And so when you think about performance, try and always relate it back to the user, right? Because there's a ton of statistics out there that say when a user doesn't have to wait, when a user doesn't have disruptions to their experience, to their flow, barriers between what they are trying to achieve and what they're able to achieve in your software, users are more successful, they like your software, they like your platform better. And that is a lot of what performance is about. So that's why we spend a lot of time trying to make performance easy on the Angular side of things. And that's why most teams end up spending and investing in this. So there's actually another way to look at this, and another reason performance matters. The Chrome team has come up with this thing called the Web Vitals. So this is, if you try to look at a single application and say, how is the performance of this application, and is it meeting user expectations? They've called out 3 specific metrics. So they've called out largest contentful paint. So this is a different way of looking at it. There's been a bunch of these kind of different metrics over the years. So for a while, there was first contentful paint. There was things like time to interactive. But right now, one of the ones that they're really pushing on is this idea of largest contentful paint. So the largest paint that happens to your UI. So that's probably going to be the paint that has all of the features that your user is expecting and all the content that user is expecting. And they're asking, when is that? How soon is that? Because the sooner you can get that meaningful content to users, the better their experience is going to be. The second metric that they talk about is called cumulative layout shift. And so this is between the start of the page and when they have that kind of fully rendered page where nothing's moving anymore, how many times did things have to move around? Because what we found is that whenever you render part of a page and then like something pops out and expands and it pushes the content down, that can create both a disruption in the user's understanding of the page, but it can also lead to things like misclicks. And so the more you shift the layout, the more detrimental it can be to the user's experience. So this is something that we're talking about measuring a lot in applications. And then the last one is first input delay. And so this one is very, very user specific and very app specific, because this is really just a measurement of when the user does do their first action, whether that's clicking on a link or a menu or a header or trying to hit a button. How long does it take before you actually respond and complete the action that they have initiated? And so this one's a really interesting one because you can't actually automate it. You can only observe it. So with largest contentful paint and cumulative layout shift, you can build a tool and you can look at my site and I say, the largest contentful paint is after 2000 milliseconds. But with first input delay, you actually have to look at user behavior, because the contents of your page and the expectations of that page are going to influence when and where they do those things and how ready your application is to respond to those things. I always like to make sure that people pay attention to what matters. So oftentimes we get questions about runtime performance, but I'm not going to talk too much about runtime performance in this application. There's a lot of best practice talks out there in terms of using things like track by, minimizing the number of change detection cycles with things like on push. But what we've seen that dramatically affects user experience is far more in the startup performance, the load of an application. So when I navigate to a URL that I want to visit, how long does it take before I actually have the content that I want? And because we have to bootstrap and we have to load all of the Angular code for the platform and the framework, as well as your code, that often ends up taking the most time. And so when the user goes to click, usually everything's ready and instantaneous. And so our primary concern when we talk about performance is that startup time performance. And the number one factor when it comes to startup performance is the size of your bundles. And so a lot of this talk is going to be talking about minimizing the size of the bundles, because what we see is that there's a direct correlation between the code that you ship down and the size of that code and how long users have to wait. And this gets more and more egregious on things like mobile devices. And so what you're looking at here is a source map where we've taken the JavaScript code of one of our production bundles, and we've mapped it back into the node modules and into the files that code came from. And so we're going to talk a lot about source maps tonight, because source maps is one of the best tools that we have to understand what's going on in our application and give us the levers that we need to pull to make that application smaller and better. So we talk about bundle size because we do find that it's the number one factor in startup performance by an order of magnitude. And I do want to call it that this is not just due to network, right? A lot of times users are on slow connections, but even if they're on a fast connection and they have a slow device, right? Like a lot of modern cheap phones are still relatively slow. Maybe they have a great 4G or 5G connection, but the device and the CPU isn't that powerful. The bundle size still directly affects that, because we have this thing, even after the content has been loaded over the network, called parse time, where the CPU and the JavaScript virtual machine has to execute and load and parse all of the JavaScript you send down, no matter how much JavaScript you're actually going to be executing. So it's not just network, but it's also parse time, especially on these kind of lower end devices in terms of affecting startup performance. And one of the most egregious problems that we have as developers is that oftentimes we don't notice this is happening. Right? We are developing on our giant 4K screens, dual monitors with a hardwired gigabit connection to the internet or to the server, or we're just building off of localhost, and we don't notice how slow things can be. And so we focus a lot on bundle size because it's very easy for developers to think they have a great experience, and then you get into the real world and they don't have a great experience. So one of the first things I'm going to point out is this idea of loading your Angular JSON. And so Angular JSON is a file that exists in everybody's Angular projects since at least the last 2-3 years. And inside of that Angular JSON file, you're going to find these two keys as part of your production configuration. And they both default to false, but I'm recommending everyone turn them to true. So the first is source map. So this is the idea that whenever we do a build, instead of just taking your TypeScript and your templates and your components and turning them into JavaScript and putting the JavaScript in disk, also save that tracking. So save that source map that maps back from the JavaScript that we're rendering and sending to the browser, maps it back to the TypeScript and the HTML. By doing that, users don't have any sort of cost to them, right? They don't actually have to load the source maps, but all of your tooling can now look at those source maps and understand it. And if you wire it up to something like Sentry or Bugsnag, you can actually use those source maps to analyze bugs as well. So when a user hits an error or some line of their code crashes, you can actually use those source maps to say, here's the thing that happened in your TypeScript, for example. And so source maps are really, really valuable, and I recommend most people turn them on. It just slows your build down just a little bit. And then the other flag that I recommend turning on is named chunks, because if you are building an application right, it's going to be split into a bunch of different chunks that the browser is going to load. The idea behind this is that we can only load the chunks that we need at the right time. And this can be a nightmare to debug if you don't turn on named chunks, where named chunks takes the file name that you had, and when we're doing those imports from those file systems, we use that to generate a meaningful chunk name. And we'll see this in a couple places, but these are two flags that I highly recommend you turn on. One of the stats that I think is really, really interesting, I don't have stats for Latin America or Colombia, but I would expect it's even higher than this, but 70% of web traffic was from mobile devices in the US. And I think that in China, that number is something like 90% plus. Mobile is the default use case for the vast majority of applications, right? Almost all your users, unless you have employees that are sitting at a desktop all day, are going to want to access your application via mobile. And so thinking about performance, thinking about bundle size is really going to have an impact for the vast majority of your customers. And one of the kind of big things that I always try and push on is that even if you are just building a tool for employees, you're building some warehouse management system or platform, the reason you don't have mobile users isn't because they don't want to be mobile, it's because you haven't let them yet. And so really trying to push for mobile and push for these great experiences across any device should be an essential part of your job if you want your developers or your users to be successful. Another tool for performance that you should have in your toolbox is bundle budgets. So again, in that Angular JSON, you're going to find this budgets key. And so there's a bunch of different types of budgets you can set. You can say initial JavaScript, you can say any script, you can say all scripts. That's the type there. And then you can say, hey, start warning after 2 meg or start erroring after 5 meg. And you can change these. And I recommend you make them as aggressive as possible, because the Chrome team, again, has done a lot of research on this and a lot of analysis where they've actually worked with teams like Twitter and like a bunch of other teams to make their applications smaller and faster and better user experiences. And they were successful in doing that. But what they noticed was a few months later, the team had started backsliding, where you don't want to make your application slower, but you're not thinking about application performance all the time. You're thinking, hey, I need this cool new feature for my users. I'm going to import this package. And you don't even realize what you've done to your user experience. And so bundle budgets are a way of making this unconscious focus on performance a very conscious and managed effort, right? You can hook this up in your CI. So when you're doing a CI, you can fail. You can say, hey, this PR is not valid because it violates some bundle budget. I also want to call it staying up to date. We're on version 10 right now of Angular. We try not to talk about the versions too much because the skills that you have in version 7, skills that you have in version 8, 9, they're still going to keep working in version 10 and beyond. But what we do is that we make every Angular release better, right? We make your code and your application smaller and faster, and we make, even without any changes from you, we make your apps better. And this is one of our kind of commitments for the future, where even if you keep writing the same Angular code, as long as you're keeping your application up to date, you're using ng update and following along with our majors, we're going to keep making your apps better. We saw developers where their bundle size in moving from version 8 to 9 decreased something like 40%, which is just crazy for not having to change your application, just get those benefits automatically. And that's something that the Angular team, because we had this opinionated control of the stack and the build system, we can look at each part of that stack and say, okay, let's move from Webpack 4 to Webpack 5, or let's add a roll-up step. And we can make that process better over time, which is really kind of amazing. And I think it's one of my favorite things about Angular. There was a really funny story where I was working with a customer and we were debugging their bundle size. And they came in and they said, hey, our homepage of our application is 15 megabytes. Can you help? And we said, sure, happy to help, right? That seems a little ridiculous, right? Most bundle sizes are less than 4 megabytes, and that's for an entire application, and they should be less than a single megabyte for any sort of home or landing page. But they had a 15 megabyte bundle, so we knew something was wrong. And so we got in, we added Source Map Explorer, we got their build system configured so we could see those, and then we started taking a look at what was in their bundle size. And what we found out was that about 14 megabytes of that bundle size was SVGs. And this is a really weird concept, because you're like, why would an SVG end up in JavaScript? And so what they were doing is they were embedding their SVGs in their CSS as data URLs. And then their CSS was component scoped. And so component scoped CSS, as you may know, is actually JavaScript. It's JavaScript code that Angular executes to scope and apply those style sheets in the right components in the right ways. And so we just took those SVGs out of the CSS and we took them out of the JavaScript, and we saved basically 14 megabytes. And because these SVGs weren't used in the critical path anywhere, that was just a net savings, right? There was no downside to any of the users. So it's these sort of things that we don't even understand until we start analyzing and start looking at our bundles. We don't see the possibilities and the ways that we can make our application better, because they were seeing that users were taking 10, 20, 30 seconds to load their application, and there was no reason for that. So I want to make sure that everyone out there be careful what you import, because importing is probably the #1 way that we see applications accidentally start getting bloated. So RxJS in version 6, we made a whole bunch of improvements with the RxJS team to make it so that you couldn't shoot yourself in the foot and accidentally import all of RxJS. So you may have noticed that we changed a bunch of the import paths back then, but it's been a couple of years now, and that's been very, very successful. So we see most developers doing things right in terms of RxJS. But we do see that people sometimes import everything from Angular material when you maybe don't need to, or they import the default themes. One thing about the default themes to know is the themes that come with Angular material are optimized if you're using every single component, every single feature of Angular material. If you are just using a single component, you should actually be taking that theme and only pulling in the styles for the components you need. So you should be creating kind of a custom wrap of the Angular material styles so that you're not registering hundreds or thousands of themes in CSS code that you don't actually need. And then we also see this happen all the time with third-party SDKs. Moment is, for some reason, oftentimes one of the things that pops up, where not only are you loading Moment, you're accidentally loading the locales for Moment 3 or 4 times. And there's a lot of really easy ways to shoot yourself in the foot. So just be aware whenever you add a dependency to your application, it's probably going to have an impact on your bundle size. And so you should look at it and understand. one of the changes that we made in version 10 that just came out very, very recently is we actually started warning when you import something that Webpack can't optimize. And so Webpack is built for this very, very strong capability of being able to kind of import code from many, many places. But what we've discovered is that if Webpack is importing code from a common JS bundle, as opposed to a UMD or an ESM, Webpack cannot tree shake away features and function calls that are never used in your application. And so we've, in our CLI, started adding a warning. So if you update to version 10, you'll actually see this warning saying, hey, your dependency isn't packaged in the right way that allows Webpack to shake away the features you're not using. And so you're going to end up paying for the entire bundle size. And so this is a way that the Angular team is trying to make all of these hidden implicit things more explicit and put them in the power and the control of developers. So I want to do a really, really quick demo where I want to show off what it's actually like to use Source Map Explorer and actually implement and improve a budget. So I'm going to flip over here out of the presentation mode. And we're going to pull over a VS Code editor. So what I've done here is I've just done ng new, and I've created a brand new blank Angular application. So this should look super familiar. You've got source folder, app folder, we've got our app component, all those sorts of things. And the first thing I'm going to do is I'm going to go follow that first suggestion I gave you. So in my Angular JSON, I'm going to change source map to true, and I'm going to change named chunks to true. And what that means is that when I go in here and I run a yarn start or an ng serve, we'll actually get source maps and name chunks. And actually, we'll do a full production build. So we'll do yarn build -- prod. So what we should get out here is a dist folder with the JavaScript that is ready to ship to a browser, right? It's already transpiled, it's already compiled. The JavaScript is ready to execute. But because we've turned on those source maps, we can actually see where that JavaScript is coming from. All right, so as soon as this is done, what we're going to do is we're going to cd into the dist folder, and we're going to install a tool called Source Map Explorer. So there's a bunch of other tools out there other than Source Map Explorer, but we only recommend Source Map Explorer because, for example, Webpack Bundle Analyzer actually analyzes your source code at the wrong stage of the process before we run Cursor, and so it can actually miss some of the JavaScript and miscategorize it. All right, so this should be done very, very soon, I hope. What we're going to see in our dist folder is here is all of our ES 2015 bundles. And not only do we have the JavaScript here, but we're going to have this .map file. And so what we can do is we can say yarn add source map explorer. Just close out of that there. So I'm going to install, so you can npm install, or you can yarn add source map explorer. It should go relatively quickly. And then what I can do is I can run npx source map explorer, and I'll pass it in that JavaScript file that we just created. So npx source map explorer, dist source maps, and we're going to say main. We'll do the ES 2015. What should happen is now we get this little window, and this is an interactive tool where you can actually see, okay, so my total bundle size for this little application is 217 KB. And I've got some of this coming from the core of Angular. I've got some of this coming from the router, common platform browser. Some of it's coming from my actual application. So here's the source code for the app component that I wrote. Here's the source code for the app component HTML. And so you actually understand what you've put into your application that's creating that bundle size. So if this, for example, application maybe doesn't need the router, maybe it's just a simple dashboard or tool, I could actually save 61 KB by removing that router. And without doing this analysis, without running source maps and doing bundle analysis, you wouldn't actually know what Angular is pulling in, what's Angular is tree shaking. So this is definitely what I recommend. The other thing I want to do in our Source Map Explorer here is I'm going to scroll down to budget. So we saw that our application was around 250 KB. So I would actually modify this to something like 250 KB, and maybe we'll error when we get above 1 megabyte. So that small change now kind of institutionalizes and manifests the size that I'm expecting my application to be, so that I don't get surprised. So this is a relatively easy change. And actually, let's even lower these further. So let's say we're going to error after any script being 125, or we're going to warn after any script is 125. So now what we should see is when we actually do a build, when that build completes, we should actually see a warning about this. And we will, I'm not going to wait for that. I'm just going to skip ahead, and we will proceed with the slides here. All right, so the next section about improving the performance of your application is really thinking about the architecture of your application, intentionally looking at the scale of your application. So lazy loading is by far and away the #1 tool in your toolbox, because in Angular generally, the module layout of your application is going to determine the lazy chunks of your application. And so lazy loading of modules via our router is the easiest way to make sure that your users are only paying for the code that they need. So you can take a look. This is an example application that I've been working on for a while. We have 14 different chunks. Some of them are styles, some of them are polyfills, but you've got things like, here's the CFP chunk, here's the admin chunk, here's the main module. And you can see that each of these chunks, because we split it up so well, are much, much smaller. And one of the surprising things is, even if all of these chunks are on your critical path, let's say you need all of this code to load your homepage, by chunking it out, by lazy loading those chunks, we're still making my application faster and more responsive, because the browser can yield back to the UI thread. It can yield back and say, hey, let's let the browser do something else, and then we can schedule and parse and load the rest of the JavaScript. And so this is a really, really common thing. If you're not using lazy loading in the router, it's very, very easy. Basically what you do is you pass in a load children key, and then you're going to import some other module. And what will happen is you take that module and you get out the actual symbol of the module. You'll notice that we used to have a string-based syntax here, but we've moved towards dynamic imports that are just natively supported by Webpack, natively supported by VS Code. And so this is a much less error-prone approach, because now, for example, if you misspell the module name, you'll get an error instead of just some silent problem that doesn't show up until you hit a runtime bug. So it's really, really easy. You just need to have a router configured and installed. And then on the child, the actual module you're loading, you need the router so that it knows what to load into that child module. But there's actually an easier way of doing this. And so if you look at this load children import, we can automatically generate this if you're generating a new module. And so there is a syntax that I'm going to jump to here. Called ngGenerate. And so if you ngGenerate a module and you pass it in a module reference and then give it a route, and like, so for here, I'm saying ngGenerate module and put it in my app module and route to the about route, and then create an about module or home module. Both of these commands do the same thing, where it creates a module with the name you give it, so about or home. It creates a default component for that module. It automatically installs and configures routing of the child module. And because you've made a module reference out to the parent, it's going to register that route in the parent module. And so if we ran these commands, we would see that it actually automatically configures the router, and we automatically have individual modules that can be lazy loaded in our app for about and for home. And so when you add more components to those modules, all of that ends up in that lazy chunk instead of the core chunk. All right, so the other thing that I was going to walk through is just this idea that a lot of people, they start with lazy loading their administrative routes, right? Administrative features of applications are often really, really heavy. We need authentication. We need often forms. We need some sort of graphical interface for editing things. All of that's very heavy, and don't make your homepage users pay for that. Don't make users pay for that before they've logged in and before they say they want things. So editors. We also say lazy load your homepage. As I said before, even if you can take it out of the critical path, or even if you can take something on the critical path and make it a lazy loaded chunk, it still yields back to the browser and gives the browser a better chance to optimize things. So lazy load your initial route. We're really at a place in the world where every route of your application should be lazy loaded. And this just gives you the right mental model for architecting and structuring things so that you load the right code at the right time. There's another way to look at this, which is that if we did lazy loading superlatively, right, we did it the best way possible, theoretically, every single line of code that you ship down to the browser should be executed. Now, this is never going to actually happen in a real application, because we need to handle errors. We need to handle browsers that have weird bugs and errors and polyfills and things like that. So you're never going to get all the way to 100%. But looking at and understanding the way you run code can actually give you a really interesting insight into how to improve your own code. And so Chrome actually has this built in. And so if you open the Chrome DevTools and you click on the little 3 dots on the bottom panel, you're going to see this coverage tab. And that coverage tab will give you a report like this. You hit refresh, and then it actually watches and instruments all of the JavaScript you load, all the CSS you load, and says how much of this JavaScript, how much of the CSS was loaded. And so you can see in this application, my main bundle was around 44 KB, or excuse me, 45% used. And my home module is only 62% used, which is very, very low for a home module. I took a look at this. So you click on that and you actually take a look at which lines of code in that module are being run, which ones aren't being run. And I found out that it's actually my date processing library. So I wasn't using Moment, I was using datafns, which is much smaller, but it was still had a ton of features and capabilities that I wasn't using that then I can use and say, hey, maybe datafns isn't the thing for me. Maybe I just need 2 scripts to translate dates into the 2 formats I'm expecting versus loading some big heavy library that can do anything for me. And so understanding the code that's being run in the browser can then make your application better. One of my other favorite things is looking at your CSS. Are you executing 100% of your CSS on your homepage? Because if you're not, maybe you should be lazy loading that CSS. Maybe you should be making components that have isolated CSS. I'm generally a really big fan of global CSS, but if you're not using your global CSS, then there's no point to having it. And then a component scoped CSS is going to be far more performant for your users. The last major section I want to go through here before we get to the future is really trying to make sure that everyone understands the JavaScript serving. And I found that this can be a big challenge for developers because we come in and we know how to build applications. We understand the JavaScript, we understand the logic, but then after we ship our application to production, there's a whole bunch of other processes that take over that can be sometimes a little bit obtuse. And so the first thing I always recommend people point out is content compression. So this is the idea that your web server and the browser both know how to compress content and decompress content very, very quickly. So quickly that it's transparent to users, even on low-end devices. And so when you ship down that large admin module with lots of features, it might actually be 900 KB of JavaScript code, but you shouldn't make your user pay for all that over their network, right? If you compress, if you do things right, you can see we're almost always saving more than half the bundle size. So oftentimes 75% of the bundle size. So imagine if just by configuring your server, you could make your application 4 times faster. That would be a big win. And so understanding how JavaScript gets served and making sure you have things like content compression turned on are very, very important. The reason I still bring this up is that I have this tool that scans a bunch of sites and looks for best practices, and we're still seeing something like 13% of applications failing to content compress their JavaScript. And so again, 13% of applications out there with a very, very simple config tweak on their server could have their application be 4 times as fast. And so that's the kind of win that we want for everybody out there. Another feature that I like to point out in terms of serving is HTTP2. So if you're using a CDN, if you're using Firebase or Netlify, you're already going to be getting all these sorts of capabilities. But a lot of people are still trying to roll their own servers, and a lot of people are using legacy hosts. And so HTTP2 is something you should definitely be looking for, because in the HTTP1 world, the old world, you basically make a new TCP connection for every request. So every time we want to lazy load, we have to call up and say, hey, where's that server? Hey, server, you got the thing we want? Whereas HTTP2, it's just a dialogue, right? You open a single connection to the server, you can download all the files without having to pay for all that overhead. So there's networking overhead, there's DNS overhead, all those things. And so you can save that overhead and pipeline those requests. That is going to be a much faster application. And there's another benefit to HTTP2 as well. So if you look in DevTools, you're going to see this protocol H2. That's how you know that you're using HTTP2. But the other benefit is this thing called server push, where the browser and the server can actually collaborate to make your application faster. So as we all know, when you build an application, there's a couple different concepts, right? There's throughput, which is how much you can send in a given time frame. But there's also this idea of latency, where every time I have to go back to the server a fresh time, I have to wait for a full round trip of my application. And so if I have a chain of events, like where my index.html loads my main.js and my main.js loads my chunk.js, I'm paying for both of those round trips, right? I have to pay to wait for the index.html to parse, and then I initiate a new connection and say, or a new HTTP request and say, please give me this extra file, and then the server responds. So it would be far better if we could improve that. And server push is a technology that allows you to do that, where you can actually configure your web server such as that when a user requests a file, you can say, oh, you're also going to need all of these other files, right? It's a header that you put in the HTTP2 configuration, and the server will just start pushing down those files to the browser. And so they'll be cached as soon as an actual reference exists to them. This is relatively easy to set up if you're using something like Firebase. So in your Firebase hosting JSON, you just say link, and then you say, here's all of the files. And for each one, you just you say rel events preload, and you can preload it as a script or a style. So you can make sure all of the files that your user needs are on their device before they even request them. Another technology that is very, very popular right now is called differential serving loading. This is the general concept that you shouldn't be sending your IE9 polyfills down to your Firefox users, right? That would be making your users pay for features that they don't need. And oftentimes we don't need to send ES5 to our users, right? Most modern browsers support modern JavaScript, which is shorter, right? You've got things like classes that make the JavaScript smaller and makes it more efficient. And so this is actually built into Angular. It's been built in for a while now. If you use older browsers, this is automatic. So one of the things we do, if you create a new project in Angular 9 or 10, you're going to get this browser list file. And what that browser list file says is, what browsers would you like to support? And so we automatically use that list to determine if a browser needs ES5 support, the older version of JavaScript, we will generate, whenever you do a build, that older JavaScript, that ES5 bundle. But you can configure this. So even if you're coming from an older application, you should take a look at your browser list file and remove the browsers you don't need, because it will save up your application build time, and it will save you disk on your CDN if you don't need those older browsers. Another technology to point out that can help performance is called Angular Universal. This is the general concept of, instead of loading your application in the client, in the browser, we also want to load your application in a pure node instance and then render it to HTML so that we can ship that HTML down to the user before the client has to bootstrap. And so it's actually able to paint much faster because we don't have to download any of the code to generate that HTML. We just can paint the HTML and then download the JavaScript and bootstrap on top of that. So the big thing about Angular Universal or any sort of pre-rendering is that it can improve the perceived load time. So the application can look like it's ready faster, and it can give you machine crawlable HTML. So if you want a share to Facebook, share to Twitter link, Twitter and Facebook don't know how to crawl JavaScript websites. And so Angular Universal is a way to solve that. You can add all the meta tags so that they know how your page should look, and they can actually generate things like previews and scrape that metadata. But this is not always a silver bullet. So one of the things that we saw is last year, basically no one was doing SSR. There were not a lot of sites doing SSR, but this year, using that same set of sites that we're scanning, so it's over 4,000 sites, more than 25% of those sites were server-side rendering. So this has actually become one of the biggest growing technologies in 2020, is server-side rendering for performance for your users. It can actually, and this is a little bit counterintuitive, using Angular Universal can increase the time to interactive. It can increase the time to largest contentful paint, because if you think about it, you're still doing the exact same thing in terms of loading the JavaScript and then rendering it in the browser and creating a page out of it. But now you're also painting a set of static HTML before that. So you're actually increasing the amount of work the browser has to do slightly. This also can result in things like where, because we're bootstrapping on top of pre-rendered HTML, if the browser started loading some of that HTML, like an advertisement, and then it deletes that and recreates it, that can also result in things like double impressions. And then you also have this idea that your page can't really be interactive until the JavaScript application is bootstrapped. And so there are some downsides, but in general, we're seeing this as a huge, huge benefit to applications, because most of the time what you can do, and we do this in several applications at Google, such as Google Shopping Express, is we will ship down a server-side rendered page, and then we'll load the JavaScript in the background. And then we'll only really bootstrap if we need to, if the page has interactivity that we need to load. There's another tool out there, if you don't want to use Angular Universal, called Scully, that will do the exact same thing for your application, where instead of loading your application in a node instance as pure JavaScript, it will load it in Puppeteer. And so you'll get out the exact HTML that a client would have bootstrapped, but then you can actually choose for every path whether you want that path to be client-side bootstrapped, server-side rendered, or both. And so that's a really kind of nice way of taking control of your application and making your users pay for the right things at the right times. So there's a lot of different options. So I mentioned Scully. You can, using server-side rendering, cache pages on request, but make sure you don't cache any user-specific data. You can do things like pre-rendering. So in version 9, we added pre-rendering in Angular Universal. So we can just take an application, you give it a list of routes, or we can infer those routes from your router configuration using some of the code from Codalizer and Guest.js, and we can just write them all out to disk. So you can also do kind of very advanced strategies where, for example, maybe you don't want users to pay for that increased TTI. What you can do is you could set up your web server to only serve that pre-rendered version to machines. So you can, there's a lot of kind of mix and match strategies here. So think about the experiences you're trying to build and the problems you're trying to solve as you're embarking on that. So the future of performance in Angular is very, very bright. We've talked about how every time we make an Angular release, we're trying to make applications smaller, faster, better, without having to make you change everything. But there's also a lot of things that you are going to be able to do in the future. Right now, lazy loading is primarily at the module level, but one of the things that version 9 and Ivy did is that we can now actually use dynamic imports basically anywhere in your application. such as that you could even dynamically load components. We don't have guides on this. We don't have a ton of official canonical guidance because we're still trying to figure out what the best practices are so that you don't have weird things like you have to do today, where if you wanted to lazy load a component, there's a bunch of different ways. Like you can load the module in the component, which is a circular reference, but that's okay. You could re-export the component from the module, but like there's all these little gotchas where you want to make sure the module context is being loaded with the components. You're not just loading the component. So that's something we're still trying to make ergonomic before we try and push it out and get everyone to do that. And there's also really cool technologies like module federation, where even beyond this idea of lazy loading within the same application within the same build, we could build separate parts of our application that could be built independently and then lazy loaded and then applied. So this is a feature of Webpack 5 that's really exciting. This enables things like micro front ends, which a lot of people are asking about, a lot of people are talking about. And so we're staying tuned a lot to that to make sure that we're really up to date with the kind of the standards and best practices that are out there. But I really want to end this presentation by talking again about the user and make sure that you as developers are having fun, right? If you don't have the best performance in your application, it's probably going to be okay, right? You're not doing the service to your users that you need to be doing. You should always do a little bit better, but it's not just I have good performance or not, right? It's always a journey that we're all on. We're all trying to get better over time. So keep focusing on delivering the best experiences for your users. And because if you focus on the user, all else is going to follow. That is it for me. Thank you so much, everyone. Y gracias.
Thank you, Steven.
Thank you, Steven.
Awesome.
Oh, sorry, I was mute. Thank you, Steven. That was great.
Yeah. I think we have a few questions in the chat. So
Yeah, do you want me to just scroll through them, or do you want to call some out for me?
Sure. We're gonna call it for you. You have some, Mayra?
I have one here. I think is interesting. Use server-side rendering in PWA will have any important change?
Sure. So server-side rendering in PWAs is actually a really interesting topic because we've done analyses that depending on the speed of a computer and the speed of someone's network connection, an SSR page can actually load faster than a PWA. And that's kind of super counterintuitive because PWAs put everything local on your device. So it's all there. There should be no network lag. But for fast computers with fast networks, we've actually seen that the parse time of a large application, so if you have like an application that's much too big, it can be slower to parse the JavaScript coming from your PWA and your service worker than it is to do server-side rendering. And so these things are not kind of like PWAs are always better than SSR, things like that. And you can use both. Generally, what you're doing is your PWA is ignoring the server-side rendered version of the application because you don't need it. If you don't have a large application, you don't have that use case I was talking about where it can kind of flip. We find that PWAs are, because it's already sitting on your machine, it's fast enough to load. And if you're doing lazy loading, you don't have to load the whole thing at once. It should just kind of be instantaneous for your users, and you probably don't need SSR. But again, if you are trying to make your PWA machine crawlable, then you need to have a server-side rendered version for the Facebook crawler, for the Twitter crawler, those sorts of things.
Great.
Awesome.
Up here, Edison has a question. I have a question. How I can optimize the speed and score point at platform page speed for mobile? I think he means that how can improve the score of the page speed.
Sure. Yeah. So the page speed index, the lighthouse scores, all those sorts of things. It's exactly the strategies I said. So the number one factor in your page speed score is going to be the load time for the initial application. So decreasing your bundle size as much as possible is going to give you a great score, right? If you can get your bundle size for your initial view or for some small individual data view to be 200 KB, you should perform pretty well.
Great. Stephen, Mario from Cali. Stephen, does NG Universal works with lazy loading?
Yeah, so it actually works perfectly. So because Universal is loading the entire application in Node, it has the same sort of APIs that it has most of the same sort of APIs that you exist in the browser. But so when you, for example, when you say load children and you pass in a lazy loaded module, Angular, based on the route that you give it, Angular Universal will just load those exactly as you would expect, exactly as happens in the browser. So it should have no effect. Angular Universal should work perfectly for any route, no matter how many dynamic imports you've got.
Great.
We have another one.
But everyone, if you have more questions, to put it in the chat.
I think
Yeah, we
Jose is
have
asking
here
how you
Jose
become an
Maya.
Angular GDE.
Yeah, that's
So our GDE program is, as many people know, our experts program, where we try and certify individuals out in the community that are both savvy about Angular. They know how it works and can kind of communicate that and explain it to other people. But they're also out in the world. They're helping developers. They're making an impact. So the easiest way is to first go out and make an impact, and then try and get a existing GDE to recommend you or to nominate you. One of the things that we say is that we don't really like create GDEs, we find them. So like if you're already doing the types of GDE activities, that's someone that's going to be a good fit for the program. Someone that's already out there speaking or blogging or training or mentoring or building cool tools. Those are the folks that make it in.
That's totally true.
so let's contribute to the community. They will find you.
I mean, I'm going to
Yeah.
switch to Spanish just for explain a little bit about how you can work for community. Una de las cosas, o sea, cuando hablamos de comunidad, no es solamente como lo que hacemos aquí en crear eventos, participar, etcétera. También hay muchas formas de colaborar. O sea, una de las cosas que yo veo que hacen mucho, pero que quizás no lo demuestran, es como la colaboración en proyectos open source. Digamos, si quieren, por ejemplo, ser parte de Angular, pues colaborar en proyectos como Angular o RxJS o quizás librerías o herramientas que utiliza Angular, o inclusive crear otras herramientas a través de Angular que le puedan ayudar. Es una de las formas, pero siempre es como ayudar a aumentar la comunidad, aumentar más personas en todo esto tema de tecnología. Yeah, I'm going to switch English again.
Yeah, there's a lot of open source projects and a lot of things to do with the Angular team to contribute. That's a great point of start, I guess.
Sorry, that mustn't. I think we have another question here. What learning resources do you recommend about server-side rendering and performance with Angular?
Yeah, so I'll actually point out 3 different sites that I think people should go look at to learn more. The first would be, and I'm actually sharing my screen if you want to take a look. The first is on the Angular.io site. We have a Universal guide, which talks all about how to set up Universal, how to get Express running, all those sorts of things, and it highlights all the tools that you can do. Like, so we in version 9 or 10, we added like a dev server and pre-render. So all of those features are highlighted here. For kind of getting started with it. Another of the tools that I called out was Scully. And so if you're interested in Scully, they've got a website, scully.io, where they talk through kind of the guide to doing that side of pre-rendering. I actually really like their strategy. I use pre-rendering via Puppeteer in a couple of my applications just because I use things like local storage, which don't exist in Node. And so that's actually one of the gaps with Universal is you're running in Node, not in the browser. And so any API that exists in the browser but not Node won't work unless you use Puppeteer or Playwright or a tool like Scully. And so I think that's a very good strategy for solving a lot of these problems. And then generically, when it comes to performance, I think talks like this are a great way to kind of learn these things. We've also authored a guide on performance. So if you go to web.dev/Angular, you can see there's a whole guide on a lot of the topics that we've talked about. So things like setting up the CLI, using lazy loading, all these sorts of things. So web.dev/Angular is a great place to look.
And there's a lot of tips you gave that they're already covered by the Angular team, right? By the CLI And
Yeah, I mean, like we try to do as much of this for you as we can. And so staying up to date, just kind of being part of the Angular community is going to help your performance over time.
yeah, that's true. Just an NG update, and you get surprised on how fast the app is now.
Yes.
Exactly. Yep.
Steven, do you have any course about Angular best practices?
It's that is a hard question to answer, just because best practice for what? The closest thing that we have to a best practices guide is a cheat sheet that we're actually working on updating right now. So the style guide. So let me pull up the style guide. So if you just go onto our website and search for style guide, I think it should pop up. Let's check here. If you Google Angular style guide, if you just search for that, it walks you through a lot of the kind of best practices of how to like build functions, how like things to do, things not to do, how to name things. So that answers some of the question, but it clearly doesn't answer all of the best practices. Some of these things, being part of a community is one of the best ways to learn. But if there are best practices you're looking for, I think we would love to hear about those so we can produce other guides, talks, videos, those sorts of things. So tell us more about the problem you're trying to solve and what we'd love to help out.
I have a little question about it, about some of the performance. I think you mentioned it on the talk, but I didn't get it very much. It's about the global variables on CSS.
Mm-hmm.
It's a good practice to use it, or it is better to not to use it and because that makes a lot of imports on CSS, right?
Yeah, so that is a very complex, nuanced topic. And a lot of it comes down to how you think about CSS. So if you are on a small team or a team with a very, very good set of designers, a set of CSS authors, global CSS is your friend, because then your CSS authors can make sure that any feature that someone builds is going to automatically look like it should look, right? Like if you just use simple HTML and you're not restyling everything for every component, there's going to be a consistency that is automatically across all of your application. That works very, very well, as I said, for small projects, for projects where you have well thought through, well architected CSS in the global space. What we also see is that you end up working on a team of 30, 50, 1,000 developers, and global CSS ends up becoming your nightmare, because now everyone wants to put something in the global CSS, and every style that someone does is overriding someone else's, and you end up like creating like more and more specificity, and then you start throwing important, like $ important or exclamation point importance all over the place. That is kind of a failure state, and that's where Angular's scoped CSS is really, really helpful. So when you scope CSS to a component, we then automatically figure out, we only load that CSS when that component is loaded, from a JavaScript standpoint, because the CSS gets encoded as JavaScript. And then we only apply that CSS to that component. And so it's got this really, really nice isolation effect that anyone can go write component scope CSS, and we're not going to hurt any other components accidentally, either up the tree or down the tree. But the downside there is that you now are potentially losing this idea of standards across an entire application. And so I think the right answer, the best practice, is a combination. So the ideal state is you have all these global styles that apply to everything in your application, make it feel consistent, make it feel logical, keeps the markup simple. Then you have component scope styles that are specific, that you have one page of your app that needs some extra style for some reason, and you can just have those there.
Cool, thank you. That makes sense.
Yeah, but I mean, it's hard. Like, I actually love CSS, and I love how it cascades, and I love how it's global. But every day I see developers getting in trouble with this. Like, it is not the easiest thing on the planet.
Yeah, it's not easy to get the standard on design, and most of the developers are not really used to on this CSS and this design. So
yeah, and I mean, like that's actually one of the reasons why I am a big fan of global style, because if most developers aren't CSS experts, then they shouldn't all be writing their own CSS to like custom style everything. The idea should be we should have shared standards that just kind of pop in.
Yeah.
Oh my God.
And if you choose a design system, fix to it. Don't,
Yeah, I mean,
don't
like
start
Material is great.
Yeah.
Bootstrap is great. Like there are lots of really good design systems out there. And if you don't know what you're doing, just pick one. Just use it as intended. You'll save yourself a lot of time.
Yeah, totally. Well, I think we don't have any question. We have a little
Just
comment.
good comments.
Yes, Natalie said, "Thank you to the entire team for bringing Steven tonight."
Yeah, thank you.
Milk.
Yeah. Thank you, Steven, for being here. Really, really nice for all of us to have you.
Thank you.
Really, really good
It's fun.
comments. Everyone is very happy.
If we can make one application faster that supports a whole bunch of users, then we've won tonight.
Yes.
Cool. Definitely. I think there's gonna be a lot of faster application after tonight.
Well,
We have a lot to do on our Angular JSON files tonight.
totally.
No more
Okay, so
questions.
Stephen, once again, thank you very much. I think there's no more questions, right?
Right.
You, Mayra, anything else you want to add?
No, just
No.
thank you, Steven, for this opportunity to be here talking about Angular. I mean, this is so important for our community. We are so
Yeah.
happy.
Thank everybody for showing up. It's been great.
Thank you.
Bye.
We owe you one of these shirts. We're gonna.
That is a
Over
great
here.
design. I would love one of those t-shirts.
Thank you. We're gonna
Steven.
have you one once
Thank you so
we can
much
see each other
for
again.
thank you so much for joining us and for your support for the Angular community.
Yeah.
Awesome. All right. Bye.
Okay. Nice. Bye bye. Thank
Bye
you.
bye.
Bye.